Oops. All right, so hello everyone. We're going to look at a new thing called the sine law, or we can actually still, but anyways, yeah, sine law. If you want to look at solutions for another Sakatoa example, I left it in here from previous times. Solving for x and y, the solutions are there, but I'm just going to leave that one for you to look at on your own and ask for help if needed. So on the sine law. So the idea of sine law, and we're also going to do a cosine law, is that in lots of situations, lots of times, it's not a right triangle. And so the tools we have to work with right triangles aren't enough. So Sakatoa and the Pythagorean theorem just aren't enough, right? If you don't have a 90-degree triangle, you can't use either of those tools. So this page here, if you print this one out, pause the video, and do what it says, you'll sort of see how the sine law kind of works or why it exists. So press pause, do that if you'd like, or keep going here. So I'm going to keep going, obviously. So if I did what it said, I have those numbers and those angles, and I find that if I do A over sine of A and B over sine of B and C over sine of C, each one's equal to about 11, 11 point something, within reasonable measurement values or errors. And then here you find sine of A. Oops, things are not lined up properly here when I pasted a nicer version of the table. Sorry. Go. Anyways, yeah, so sine of the angle. So notice what we're doing there is we're doing side A, right? Let's go with green here. So side A over sine of angle A. And then the other one is side B over sine of angle B. And side C over sine of angle C. We have these like opposite angles, right? So it's side over opposite angle. I might just get rid of one of those. I'm going to call it crisscross when we get at it here. So side over opposite angle, just a little easier to see, but not all of them circled. Okay. But yeah, we get the 11.2s from the side over sine angle and sine of angle over opposite side. It's giving us like 0.89. It's really just 1 over the 11, right? Thanks for waiting that. So what you're seeing there is that there is something true about non-right triangles to do with the sine ratio that the calculator can calculate for us. And I'll try to make more sense of what that really means when we do cosine law. It's a little easier to describe. Right? But for now, we can just see that it's true. And so we get from this, for any triangle ABC or any other letters, of course, the sine law is this. Sine law is if you have A over sine A or B over sine B or C over sine C, they're all equal to each other. Okay. We definitely can think of it as this way as well. What we're going to be doing is if I'm looking for A, I'm going to start with A on the top. If I'm looking for angle A, like side A on the top, if I'm looking for angle A, then I'll start with sine of angle A on the top, and same for any of the other letters. Okay, that's what I'm going to show you to do, just as to make it easy to use sine law. Notice that since even though there's 3 ratios, we're typically only going to use 2 in some problem. So if we knew angle A, side B, and angle B, then the only unknown in this portion of sine law is A, side A, so we can solve for it. Or if we know B, angle B, and side C, we'd be able to figure out angle C in that portion of it. And that's how it's going to work. And again, if you're asked for side C, then you just start with, if you're asked for, angle C, start with sine C and work out a rest of a ratio set that If you're asked for A, start with it on the top, kind of like we did for the ratios with similar triangles. Okay. So using sine law, that's a big thing to watch for first as well. When do we use this thing? And you'll notice from the other page, it works the same kind of way. It's like I want side B, and I have the opposite angle, and I have side A and angle A. And so if you have a crisscross of information, right? So if you have a crisscross, right? You have crisscross information where you have everything except one. So you have all of these ones and you have one missing only. You can solve for that. Okay. So what I'm going to show you, of course, is to start with the one that you want to find and start with it on top. So it's going to be easy to solve for. Okay. So that'll look like this to start out with, where we got the B. And then it should be pretty obvious at this point, you know, the B is on the top. So sine of B is in the bottom. And so I'm going to show that as like the value, because you really could just go to over sine 50, but really it was because it's, you know, B over sine B, right? And then what's that going to be equal to? And again, slow the video down, unless you want to press pause, whatever, right? So yeah, that would be equal to an A over a sine A or a B or a C over sine C. So in this case, you can establish just the other numbers, you know. So it's going to be the 10 over the sine of 25, right? 10 over sine of 25, which obviously is, you know, A over sine A. But again, I'm not requiring you to write B over sine B equals A over sine A. You can just go right to the numbers. Make it easy. Okay, so in your work that you submit, don't worry about the letters. Just use the crisscross and put numbers in the way they should go, and it should be nice and easy. Okay. So you're going to do some calculations, of course, right? You can just do the actual sine of 50 and get this number, and do the sine 25 and get that number, and so on. So that's all the calculations done. And then, of course, to solve for side B, you just need to multiply by the 0.766 number, you know, whatever the decimals were that you kept, right? So multiply that on both sides. And that, well, actually, shouldn't cross that out yet. Do that for 0.766. So we just need to do 10 times 0.766 and then divide by 0.43, or 10 divided by 0.43, 423, sorry, and multiply by 0.766. Either order is fine. We get 18.1, right? So that gives us a value here of 18.1 for that side. Right, so this page and what I've just shown you now helps you decide when you can use Sine Law. You get crisscross information. That's going to be more important, of course, later when you have other types of questions, right? So you might not have that kind of combination information, in which case you can't use Sine Law. Instead, you might be using the other one, which is cosine law, which we're going to see in coming days. So here we obviously chose Sine Law and looked at it. This is what's solved when we're solving for a side. The other possibility, of course, is if we are solving for, that's just the blank version of the page there, if we're solving for an angle. I have this left so that you can print it, right? If you want to follow along and so on. So the one, if we're solving for an angle, on that page actually first. There we go. So yeah, when we're doing this, we're going to use the previous example just to show that we can solve for the angle and see that we get the right answer. So we know the angle really should be 50, right? So I have this set up now where it's like, well, if you're given the 18.1 side and you're asked for angle B, right? Then you're looking for angle B and so on. And again, you would have done this. You would have said, oh, I'm looking for angle B. I've got the opposite side, and I've got another pair of opposite side and angle. And so I can use sine law. Let's see. That's crisscross means you can use sine law. And so you go ahead and start using sine law. You're going to have sine of B. We're going to start with sine of B, and it's going to be over the 18.1, right? You might as well start with the one you're looking for in the top. Makes your algebra easier. And so, yeah, sine of B over 18.1 is going to be the sine of the other angle, you know, over the other side, you know. So the sine of 25 over the 10. So evaluating numbers here, I did a little bit more in one step there than I would normally do. So obviously you would have get this thing here as a number, right? And then multiply both sides of 18.1. So whatever sine of 25 is times 18.1, and divide by 10, and it gave the 0.7649. Okay, so this is gone. We would have had sine B here. And just to show a little bit more here, sine of 25, make sure you're calculating degrees, of course. So sine of 25 is 0.4226 and so on, multiplied by 18.1. So I'll write that as actually sine of 25. So what we're doing here is we have the 0.4226 times the 18.1, possibly more decimals there too, and dividing by 10. So times 18.1 divided by 10 gives us the number there. Hopefully, I didn't quite get it here, but 0.4226 times 18 divided by 10. Yeah, gives us 0.764 and so on. And typo the first time I did it, I guess. Yeah, so basically we have sine of b equals that. And so what do we do to get the angle? Right, we're looking for that angle. We need to get rid of sine, which we saw recently as well. Right, so getting rid of sine, you do sine inverse of that 0.76, and you're left with what b is. And the calculator's spitting out, depending on how many decimals you get, 49.9 or whatever, but obviously that's the 50 that we started with originally. Okay. So that's just solving for a side and then solving for an angle. And the other thing to be able to do is just like solve a triangle. So solving a triangle means to get all of the unknown values. Okay. This question was originally, I modified it, but originally it was just solve for this angle. And so that's set up to be a sine law, right? Because you've got reciprocal relation. And it just kind of makes it almost harder to pick that out because there's other things, right? But you can tell here you certainly can't use this information if you don't know either of them. So you're not using that as part of your sine law and so on. Okay, so this is what I can solve for first. Right? So if we're looking for angle E, you're going to start with angle E. You're going to say sine of E. And you're going to fill in a sine, the rest of a sine law pattern. So sine of E over 20 is going to equal another sine of an angle over an opposite side, which is sine of 68 over 22. Right? And so just like before, we can calculate out, I'm just going to do one step this time though. So 20 multiplies on both sides. And we have sine of E equals all that stuff. So just recognize you have to do this first. You can't do 68 times 20 and sine of that. That doesn't make any sense. It's not what the ratio numbers are. So sine of 68, get that as a number, 0.927 multiplied by 20 divided by 22 gives us 0.84-ish. 0.84, 289, I'll say 0.84 dot. Worry about looking like I rounded wrong. Sine inverse of both sides. Gets rid of sine, gives it just E. Angle E. So sine inverse of that number is 57.4 degrees. Okay. So that got us the angle 57.4 here. So to do the rest of this question, again, press pause, think about it, someone be an active learner, then press play and we'll do the rest here. I think the next step you have to do is look at the fact that the angles in a triangle, of course, add up to 180, right? So we have the 68 plus the newly found 57.4 and adds with angle D, the other angle. So we can figure that angle out. Just subtract 68 from both sides and subtract 57 from both sides. Or you could have added them up first and then just subtracted the total of them. But it doesn't really matter. 180 take away 68, take away 57.4. I think I have that number. So that should be 54.55. So it's 54.55. I'll just do this for now. 55 dot and so on. So I'm going to round that to 54.6. So now we have another value from the triangle. We've got the E, the D, and do that now. It's a little hard to see if I keep going on the crisscross whatnot on the triangle, but if I have this written in as 54.6, then you can see if we could do another crisscross here to find that side. So if I'm doing that, I'm just gonna switch that. And so if it's another crisscross vertical, right? So now we're looking for side D, right? Or call it side B or side ER, doesn't matter. It's just a little another cross. That's what we've been doing so far here. So we're looking for D, and that's over the rest of the sine ratio, right? So you have D over sine of 54.6. Done that all in green, so it'd be that green crisscross circle there, and then just one of the other ones. So I think I'll change that actually. I like color coding. So yeah, D over sine of 54.6. We need another ratio of sides, so we might as well use the original one. As I go 22 over 68. So 22 over the sine of 68, of course. Don't forget to do the sine of it as part of it. I said over 68, but I should have said, I suppose, sine of 68. And so this one feels tempting to get number versions. You could multiply both sides by sine of 54.6 as well. That would be totally fine. But let's see if we get, I think I will do that actually, because then I don't have to worry about carrying numbers as far as long, right? So if I multiply by sine of 54.6, that's gone. Multiply by sine of 54.6, and you just get your numbers. So we're gonna have D equals all that stuff, right? So I can do the sine of 54.6 maybe first, just to anchor it in. Hit enter, got 0.815, multiplying by the 22, and then dividing by the sine of 68. If you're not positive, your calculator is doing the right stuff. Just write up the numbers individually, right? So just got a number that didn't make sense. So bear with me here. Sine of 54.6 is 0.81 multiplied by 22. And then we're dividing by, I'm going to put brackets to make sure it does what it's supposed to do. Sine of 68, bracket, stuff like that. And it's giving 19.2. That makes some sense. The answer I just got was like 0.8 or something like that. Clearly I hadn't done something right with the calculator. Side length of something, 0 point something wouldn't make sense in that triangle. It's good to notice that if you have numbers that don't make sense based on what the situation is, gotta notice that and fix it. All right. So that is it. That is what's called the sine law. For when you're working with triangles that don't have 90 degrees. So you can see same stuff here, solving for a side, solving for an angle in 2, and then in 3 solving three and I guess 4. Let me get rid of 4. Let's get rid of 4. And we'll tackle that in a separate lesson. If you're not given the picture and whatnot, but totally could do it, I'm sure. But we'll have a lesson dedicated to if you're not given the picture. Obviously, it's just a good extra practice, right? Obviously, you just draw the picture properly and calculate the missing pieces. All right. So that is it for today.